In this example, we will use the vector pair 3, 4 for v, and w equals 1, negative 5 to find the dot product of v and w, or v dot w, and the angle measure between v and w. We'll round the angle to 2 decimal places if necessary. Now to find the dot product of v and w, it's relatively simple. We do have a couple different formulas for that, but the primary way of finding the dot product is simply to multiply the associated components and add the results. So by that I mean we'll take v dot w as the first components multiplied, which would be 3 times 1, as well as the second components multiplied, which would be 4 times negative 5, and add the results of that. That gives us 3 times 1 is 3, 4 times negative 5 is negative 20, and that gives us a dot product of negative 17. Now that's all there is to it to calculate the dot product using the components. But we are also tasked to find the angle measure between v and w, for which we will use the geometric interpretation of the dot product. The geometric interpretation of the dot product is that v dot w is equal to the magnitude of v times the magnitude of w times cosine of theta, where theta is the angle between vector v and w. This is the other formula for a dot product, but we will not use it to calculate the dot product itself. Instead, we'll use this to calculate theta, since we now know the dot product and can pretty easily solve for the magnitudes of v and w. So before I do progress any further with this equation here, let us find the magnitudes of v and w so we can work with those. The magnitude of v, to find the magnitude, is just the Pythagorean theorem of the two components squared and added. So that would be 3 squared and 4 squared for v, which is pretty nice as that will simply be the square root of 25 or just 5. W, arguably not as nice there. We have 1 squared and negative 5 squared added and taken a square root of. Well, 1 squared is 1 and negative 5 quantity squared is 25, so that's overall root 26, which I'll just leave it as it is. Not much more I can simplify with that. But now I can use the geometric interpretation of the dot product to solve for theta. Theta here would be arc cosine of the dot product divided by the two magnitudes. So v dot w divided by the magnitudes of v times the magnitude of w. And we now know everything on the right side of my equation here. So we should be able to solve and get the value on the left, theta. That will be arc cosine of the dot product we found was negative 17, divided by our two magnitudes. V was 5 and w was square root of 26. We need arc cosine of negative 17 divided by 5 times square root of 26. Quick note, do pay attention to your dot product here. It came out as a negative, and that is the only thing that could make the inside of this arc cosine function negative. That's relevant because the output for arc cosine, which is defined from 0 to, in this case, I'll say in degrees, 0 to 180 degrees. If it's negative, it more specifically is going to be in the quadrant 2 range, so negative or 90 degrees to 180. If the dot product was a positive, though, we would be expecting an acute angle measure between 0 and 90 instead. Here we expect an obtuse one, so let's break out our calculator and approximate this. I'm going to get this into degree mode, so let's make sure that we are in degree mode for that purpose. We have arc cosine of negative 17 divided by 5. 5 times square root of 26. Make sure that root 26 is actually in the denominator. So parentheses are your friend if you do that all at once. And that gives us an obtuse angle measure, as I expected, of 131 point to 2 decimal places, 0.82. We now have both the dot product and one of the things the dot product can help us find, the angle measure between the two vectors.